Okay, thank you, Pia. Nice to be here. Of course, you know Valmet. We serve pulp, paper, and energy sector by technology and services. So the both are in our thinking. This one is about being agile in our environment of B2B, and using analytical discovery as one of the tools for being agile. I want to start this presentation by a slide I stole from Pekka in the Tieto when he was talking to us. It's about industrial internet, almost like a definition, as Valmet is using this word instead of IoT or IIoT. It's about smart machines, smart people, and smart processes working together. And by doing so, the sum of these three should be more than just three. This presentation is more on the underlying topic that it almost always includes analytics and actions for users. And this one is about analytics and actions of users in this type of heavy industry compared to the consumer side of it. And if you then follow the hype curve of things, the analytics and the terminology here associated are artificial intelligence, machine learning, deep learning, and also shallow learning, if you will. This short presentation is actually in three parts or in three sections. The first one is called From Selling to Collaboration. It's about the trends we see in our business environment when we sell and deliver our technology and services. The second one is one practical showcase or example on analytical discovery on actually energy optimization on a paper mill to save energy, and the short summary after that one. In our business as well, in your business, there is a growing number of customers, at least in B2B, who are seeking more deeper vendor-to-customer collaboration. So in these 2 bullet points, UPM being one of the largest in Nordic and International Paper being largest paper company in the globe, are both talking about need for less vendors and more deeper cooperation or collaboration between vendor and the customer. Some of the motivations why you should be interested in, or why our customers are interested in such a deeper cooperation, is joint innovation, bolder innovation, maybe bolder strategic moves if you are doing so. Joint development, data sharing, if we talk about analytics, is a requirement. And then on a business perspective, from transactional selling to long-term agreements. Another dimension to this discussion is, of course, a transformation that all this digital community is talking about, that the physical goods and the services we do are merging closer together into one. And that type of customer journey is also very relevant for B2B and for Valmet. And one can, of course, ask, what kind of steps have you been taking? What are the steps Valmet has taken in order to move on this combined services and products? I discuss here only on terms of, let's say, analytics and IoT. There are 2 clearly distinguished steps we have taken. One is that we have generated ability to gather, collect, analyze, combine large data sets of industrial data, because that is almost like a basic requirement for doing relevant additional value in collaboration with your customers to improve the insights. More recently, we have also reformulated sales and delivery processes to be more agile, putting this type of capability into modularized, agile, let's say, analytics for customer as service. We have done several cases in a way in a connection with our customers, so that we sit together, we do analytics together on the issues that are business critical for them, in order to bring more insights as we do it together. We call it analytical discovery. It's modularized. It has 3, let's say, portion of it: getting the data, profiling the data, preparation meeting with the customers to know which of the questions we're going to answer, and then a workshop or a data discovery process. We have several ways to do it. One way is to collect online and be online connected to the mills and machines that we serve, or by a batch load process of getting data. Being able to do so, it's about the ecosystem. Of course, in our case, the ecosystem starts on the machines we deliver and the control and automation systems we deliver with the machines. That's the foundation. If we move on right upper corner, that's the infrastructure and the ecosystem for analytics. We use Teradata, we use IBM in order to be agile, in order to do advanced analytics. Then when these results are turned into actions, we use companies like Midakon, who is here, to help on the change management if there are things that the humans or the operators need to change in the way how they run or operate the machines. We have several cases, several customer cases that's done together with the customer, that has been brought up by the customers and done with this approach. And these are now grouped in some kind of customer need category. All of them are basically speaking about saving energy, saving raw material cost, saving in total consumption of spare parts or wear parts. All relevant for the industry we serve. In here, I'm going to demonstrate you what was the process and how did we look on agile manner energy consumption of one paper machine line in Europe. The business value of the case I'm going to show is €500,000 per year for that specific machine. And it's actually a very well maintained machine, and the number of paper machines and equal lines in the globe is 5,000, so that's a basis for a global impact. If we take this energy saving value into perspective of households in Central Europe, they consume 5,000 kilowatts per year electricity per house, and that's about 1,500 households worth of saving that can be found. You can't do this type of work. You can't do customer insights. You can't do value if you don't integrate data wider than you normally see. Even the paper mills are nicely connected and nicely handled. There are still several silos of data. A basic requirement you need to have is ability to integrate these data sets, which is then happening in our case in the back end of the back-end analytics systems. Here you see in green roughly 10 different data sources you need to acquire, put together for analytics in order to do such things for your customers. We have identified a 5-step approach, easy to follow. First, you look the whole thing, whole 200 meters long paper machine. Then you don't eat the elephant at once, it's too big. You slice and dice it into decent sized portions, which are then in this industry called sub-processes. You identify which of them is causing you the problem, in this case the energy consumption or variance of energy consumption. Then you dig in deeper what is happening there, and eventually also look the operators and the things the humans are doing in this phase. Then you think if it's justified, is it done for purpose or not? You create models, you do what-if scenarios, and you do change in your customer's environment. This is what it looks like if you're a paper maker and done this type of analytics. It's about 8 different types of papers this machine is producing. For you it looks same white paper, for them and for us it's different. The raw materials are different, the parameters are different, they are run on different recipes. On x-axis it's a specific energy consumption, so how many kilowatt hours electricity is consumed per 1 ton of output. In x-axis is the output rate, how much we are doing papers. And as you can see, this system, this type of industry doesn't produce just one, it produces many outputs, and the specific energy varies accordingly, according to the grades and according to output parameters. 10%, roughly 10% is the, if you look how thick this span of energy consumption is, so that's about the thing we are interested in. How can I save 10% of all I'm using? To be faster, I only pinpoint you that, okay, one of these sub-processes, one of the slices of the elephant is actually consuming 90% of everything we see. In the same kind of graph, you see that, okay, some of the grades, if you will, this green grade, you can run it with 150 or you can run it with 200. Why don't you always run it with 150 and save? Save costs, be more cost profitable. And that one part alone is equal to 1,500 households. Then when you dig deeper and you look what kind of machines are in this portion of the paper machine, what is happening there. We also done, let's say, the operator shifts and the machine tenders who are running this machine comes into play. The shifts being on different colors. This paper machine is run 24/7. It has 5 or 6 shifts. Apparently the yellow shift is doing better than the rest of them, running this specific equipment in smallest possible energy consumption. The customer has no clue, can't do this type of approach without analytics or our or somebody's help. Then when you go further, you have these happy 5 groups here operating this machine. Of course, you question with the help of yourself or somebody else that why do you run this differently? What is the motivation of individual crews to operate that machine in specifically this part differently? Asking with this customer, we get 4 different answers. One says, yeah, I'm using this one and the strategy here for end product homogeneity. Somebody says it's stronger, the paper is stronger if I use it this way. Another one says, well, there's less downtime in this machine. And the last one says, yeah, the end product properties are better. In this case, none of these are actually true. So we have humans interpreting a very specific part of this machine, why I'm using it. It's basically a recipe. It's a thing when you change the grade end product. This one is recipe-based. Humans are learning by, let's say, trial and error, and these operators come up with different reasons why to use this part of the machine. 2 things that the mill or the owner can do. A, copy-paste the yellow shifts, the one that was running it with the lowest possible energy, and just put the others run it in the same way. Or maybe you can replace this part by some pipe or something and stop using, put this unnecessary part away and don't put any human interaction in this place, and you can save 1,500 households worth of energy. We have several such cases. We are interested in human-to-machine interface. We are making intelligent machines as Valmet, so that's been taken care of. Connectivity is there. And now looking what how these humans are operating these machines, it's somewhat new. The technologies enables us to do and dig deeper, make things better. Why should we be interested in such a thing? The research shows that data-driven companies are 5% higher in productivity. They are 5% higher in profit. Their market value is 50% higher than the peers. We should be highly interested in delivering insights by data, by analytics to our customers to move them forward. This presentation or this approach is easy. Putting data together, discover new things. These are not possible to be discovered by any other means. If I audit the mill, I see only one day. For this approach, I need whole year of data. I see very limited in the old-fashioned manners. So discover new things, do it together with your customer in a collaboration mode, predict the future, do what-if scenarios, and optimize. That's my short 20 minutes. Thank you for your time.
Thank you very much.